Can you close your covers? Come have a seat on the floor. Bring your whiteboard and marker. What happened to your whiteboards? Here, I have two.
Thank you.
It's for the whiteboard, not for your arm. Everybody have a marker. I gave your table too. All right. Good morning, everyone.
Good morning, Miss Anna.
Okay, before we start, scouts, really quickly. Dominic and Ashlyn.
Ashlyn already went.
It's okay. I think everybody has gone.
No.
No? Well, we'll have new scouts tomorrow. Okay. So scouts, while we're down here, okay, I want you to be looking for people exhibiting behaviors associated with the 3 B's, right? Being safe, being responsible, being respectful. Whiteboard marker, come on, down here. Can somebody give me an example of what it looks like to be safe down when we're down on the floor? Not slow.
Not hitting anyone.
Okay, yeah, not hitting anyone, that's good. Alana.
Keeping your hands and objects to yourself.
Okay, yeah, keeping your extremities to yourself. Okay. If you have to come up to the board, right, should you be stepping on people?
No.
No, say excuse me, right? If you hear excuse me, you need to move or come around the side, right? There's kind of a little path right here. Okay. Dominic, just so you can see, because you're one of our scouts, can I have you switch places with Kathleen? So, you guys are both sitting way up front. All right. Okay, can I have an example of what it looks like to be respectful? Damian. Okay, being nice to each other. What would somebody who's respectful sound like? Nima. Okay, they're going to use kind words. What if you, what if I picked on Anthony to answer a question? Would it be very respectful of you to shout out the answer?
No.
No, right? What if you really know the answer and you really want to share, but it's Anthony's turn? Should you shout it out?
No.
No? What if I ask you to give him help? Then is it okay?
No.
Yeah, okay. Well, don't give him the answer, but you can help him, okay? How about being responsible? What does it look like to be responsible? Damien. Okay, doing your work, right? What else? Yolani. Okay, using appropriate voice, right? So if you're sitting way in the back, should you be quiet like this? No, right? use a level that we can hear.
No, Jack.
Okay? What if you're talking to your neighbor? Should you be talking to your neighbor like this?
No.
No, right? You're going to give them hurt ears if you do that. Okay?
Headache.
Yeah, headache. Okay. So over the weekend, I did some research about how children in Singapore do math.
What is Singapore?
Singapore is a country. Okay.
It's like
It's in, yeah, it's near the Philippines. Ashland's right. Okay. Kind of right below China. And their Ministry of Education, kind of like our Department of Education, 50 years ago, they did research and they found that they were really, really bad at math. Like, really bad at math. Okay? So they did about 15 years of research on how children best learn math. And they rewrote all of their textbooks so that they have the best ideas and research in their math textbooks right now. Okay? What happened because of that? Now they're really, really good at math. They're like one of the top 3 countries with the highest number of students who are proficient in math. I think it's like 95% of their students are proficient in math.
proficient.
Yeah. That means given any problem, they know how to solve it.
You sure?
Yep. One of the methods that they use to help them solve problems is something called the bar model. Okay? And that's something we're going to practice today because when we were in data teams on Friday, we looked over your math tests and you're very good when I give you problems like this. Okay? Almost 100% of you would get problems like this, standard algorithm problems, correct. Where do you think we need to work on? Division, but specifically what type of division problems?
Long division.
Long division, so like this?
Oh, that's way.
Long division?
That's easy.
So standard algorithm long division problems or word problems?
Word problems.
Long division.
Okay. Who thinks we need to work on word problems?
Kind of.
Yeah. Okay. So that's what we're going to be doing today. So I'm going to show you this bar model method. And this can be used for any kind of word problem. Doesn't matter what it is. Addition, subtraction, multiplication, division, percentages, fractions, ratios, which we're going to do next module. Okay? Don't worry about it. Okay? Any type of math computation problem that involves words, you can use this method. Okay? So now you're probably all wondering, Mrs. Allen, what is this method you're talking about?
You're going to write that.
I'm going to show you. Okay? So I'm going to start it off with a multiplication problem because we're better at multiplication. Okay? We're going to do it together for a division problem. Okay? But I'm going to have you also practice it with Sal using unit conversions. Okay? So we're going to practice it a couple ways. All right. So here's our multiplication problem. Anna saved $8 every week for 5 weeks.
Oh yeah, I see.
How much did she save altogether? Okay? So here's what we need to do first. We need to write our math statement. Okay? Our math statement comes from the question. What's the question we're being asked?
What's 8 divided?
What's the question we're being asked? Ashlyn.
How much money did Anna save in 5 weeks?
Okay, so how much did she save altogether? Okay. So altogether, she saved, we don't know yet. We haven't done the problem. Okay, so we're going to leave a blank spot. Okay, so I want you to write this on the bottom of your board. Okay, take 20 seconds. Write this on the bottom of your board. Just this statement. You don't have to write the problem. It's already up here. Just this statement. So all together, she saved line. Don't forget to put your unit.
Altogether. Word.
Okay, so all together, she saved. Okay, I know you're done when your cap is on your pen, your board is in your lap or on the floor, and your eyes are on me. Okay. 10, 5, 2, 1. Okay. All right. So this is what we need to figure out. Okay. One of the other strategies that kids in Singapore use is they go through every single part of the problem. They kind of chunk it like how you would chunk reading, and they write down all of the important details. Okay, this is really, really helpful for when you have problems that are like super, super, super long. Okay, so let's start. Normally we would stop at a period, so we're going to stop at the period. Okay. However, if there's a lot of information in one sentence, we're going to stop after important information. Okay, so let's start right there. Okay. Anna saved $8 every week. Stop. How much did she save every week? $8. Okay, this is where they get the term bar model. Okay, so we know how much she saved every week. So I'm going to draw a little rectangle. Okay, this is the amount of money she saved in 1 week. Okay? For 5 weeks. So how many weeks did she save $8 for? 5. Okay? Did she ever change the amount, did she ever change the amount she saved? No. Okay, so I'm going to draw 5 rectangles that are all the same size, about. Okay? Okay? This is where they get the term bar model, because you can see her 1 week, her single unit, right? We repeated it 5 times because she saved that much money for 5 weeks. Okay? So at the end of 5 weeks, how much did she save? Well, 1 unit is equal to $8. 5 units is what we're looking for. So I'm going to multiply $8 times 5. $8 times 5 weeks is how much? $40. Okay? Is that what you got?
Yeah.
Yeah? Okay, so let's answer our statement. Altogether, she saved $40. Okay? Does this seem really, really hard to remember?
No.
Yes? No? Okay. Your opinion? Okay. We're going to practice it. I don't expect you to master it by the end of today. No way you could possibly do that. Okay? Okay? There's no way you could possibly master this by the end of today because you have no idea how this is used in each different kind of problem. Okay? So this is how we would use it in multiplication. Addition might be something that looks a little bit similar because multiplication is just repeated addition, right? How would you use this in division? Okay, so that's what we're going to test next. All right, so we have another super saver on our hands. Mr. Ben. Ben saved $400 in 5 weeks.
What?
How much did he save? Whoops,
20.
I can't spell.
$20.
Excuse me. How much did he save each week? Okay. So what is the question asking us to find out?
How much?
What is the question asking us to find out? Kathleen? Yeah, okay, so let's turn that into our math statement. So he saved, or Ben saved. Do we know how much he saved?
It's 40.
400.
Do we know how much he saved?
No.
Nope. Okay, so he saved a certain amount, we don't know, each week. Okay, write that at the bottom of your,
Ben saved. We have no idea.
Can we write he?
Blank.
sure. Okay, so Ben saved some amount, we don't know yet, each week.
W-E-E-Q.
10.
Oh, I got the answer. I got the answer.
No, it's not 400. I just please.
2, 1. Okay. All right. Let's go through like how we did with the other problem and chunk it out to find the important information, right? Okay. So here's what we need to figure out. How much did he save each week? Ben saved $400. Stop. So how much did he save? Was this 1 week's saving or was this all together over 5 weeks? All together over 5 weeks. Okay? Let's use black. Okay? So all together over 5 weeks. Ben saved $400. Okay. What we need to figure out is how much did he save each week? Okay. Do you think he saved the same amount each week? Yes? Okay. So I can take my whole and divide it up into parts. How many parts would you divide it up into? 5? Damian, why do you say 5?
Because she said Ben said it's in 5 weeks.
In 5 weeks? Okay. 1, 2, 3, 4. Okay? So now we need to figure it out. Okay? We know that 5 units, in this case our unit is a week, is equal to $400, right? Well, to figure out 1 unit, we would need to divide 400 by 5. Okay?
What is the U for?
Units.
Oh.
Okay? 400 divided by 5. Let's do long division way. Okay? Can 5, well, can 5 fit into 4?
No.
No, let's extend it. Make it 40. Can 5 fit into 40?
Yes. 9 times.
8 times.
8 times. Okay?
It's 80.
So how much did he save each week?
80.
80 what? Goats?
$80.
Thank you.
80 million, 8,000.
So that's long division.
Uh-huh.
I'm not supposed to be like more.
Okay. All right. You ready to solve one with Sal? Yeah? Okay.
What's that?
His is going to be a little bit different because he's working with, instead of weeks and money, he's working with centimeters, meters.
Oh, I see it. It's over there. Oh yeah, remember that?
Oh yeah, Henry died.
Nima, can you just turn off the middle light? Yeah, there you go.
Convert 37 centimeters to meters.
Okay. I can only raise the volume up a little bit. So if you want to hear, we have to keep our mouths shut.
37, I'll write centi in a different color to emphasize the prefix. 37 centimeters, and we want to convert it to meters. So we really just have to remind ourselves what the prefix centi means. Centi literally means 1/100, or 1/100 of a meter. So this is really saying 3,700 meters. So let's write it that way. This is literally 37 hundredths of a meter. So 100 meters. These are equivalent statements. So what are 37 hundredths of a meter? Well, that's going to be 37 hundredths of a meter. That's going to be 37 hundredths of a meter, which can be rewritten as, if you wanted to write it as a decimal, that's 0. You could do it as 3/10 and 7 hundredths, or 37 hundredths. So 0.37 meters. Another way that you could have thought about this is, look, I'm going to go from centimeters to meters. I need 100 centimeters to get to 1 meter. So
Okay, I'm going to pause it right there. I know we already know the answer, but I want to see if we can show what he did using the bar model. Okay? So the reason I let it run through is because it reminded you how many centimeters are in 1 meter. Okay? So it says convert 37 centimeters to meters, right? It's not really a question. It's not shaped like a question, but it kind of is. So how would you write the math statement? How would you write a math statement, Ashlyn?
I would put 37, 100.
So remember the math statement is the answer to our question,
Yes.
okay? So he's asking, basically what he's asking is, how many meters are in 37 centimeters? How would you rephrase that as a statement? Damian.
7 centimeters is the center.
Okay. So 37 centimeters, I'm just going to put the abbreviation, is equal to, we don't know how many meters yet. I mean, we know because Sal solved it already, but if we hadn't watched him solve it, we wouldn't know. Okay?
I know.
Okay. 37 centimeters is equal to some number of meters. We don't know how many yet. Okay. But here's what we do know. Right? Centi is, he said, 1 over 100. Okay. So if you broke your unit up into 100 pieces, 1 centimeter would be one of those little pieces. Okay? So here's our units. Okay? This is 1 meter or 100 centimeters. Okay? What we want to know is what part of this meter equals 37 centimeters. Okay? No, I have that backwards. No, wait a minute. Yeah. Okay. So 1 meter is equal to, no, this is not right. 1 meter is equal to 100 centimeters. Okay. 100 centimeters times 37, we get 0.37. And I know I'm doing this wrong. In my head it makes sense, but this is probably wrong. Wait, what did he do? Ah, that's why. Okay. So 37 centimeters is equal to 37 hundredths of a meter. Is it a full meter?
No.
No, it's not a full meter. Okay. Because we need 100 of those in order to be a full meter. We didn't have 100. We only had 37. Okay. 37 out of 100. Okay. Maybe I'm hoping the next video I show you will help you kind of remember the prefixes, because it's not just centimeters we're going to be working with. We're going to be working with millimeters, hectometers, okay? All of that.
Kilometers, meters.
know, I figured out how to memorize the metric system. It's all based on powers of 10. So you just need to memorize a couple Latin prefixes, and then you can measure anything. Just remember King Henry. Oh, you don't know about King Henry? Listen
I
up.
remember this.
King Henry died drinking chocolate milk. King Henry died drinking chocolate milk. King Henry dies drinking chocolate milk. King Henry dies drinking chocolate milk. It goes kilo, hecto, deca, deci, centi, milli, weight. Kilo, hecto, deca, deci, centi, milli.
King Henry ordered cocoa by the kilogram. That's 1,000 grams. We could barely fit it in the van. The driver drove over a hectometer. 100 meters, you know, AC in the two-seater. I was feeling like a joker in a deck of cards. Milking cows by the decaliter in the barn. 10 liters at a time when I saw the van driver and gave her a piece of my mind. I whispered at a decibel, 1/10 of a bell, saying that King Henry wasn't checking his health. She made a figure small, like a centimeter, 100th of a meter, and said, please believe her. If he gets this much bigger, he might explode. I agreed, even the milligram of cocoa. 1,000th of a gram might change the throne, cause hot chocolate can make a king turn cold.
King Henry died drinking chocolate milk. 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 It goes kilo, hecto, deca, deci, centi, milli, weight. Kilo, hecto, deca, deci, centi, milli. Kilo, hecto, deca, deci, centi, milli, weight.
Can we see it again? This is interesting.
Okay. So if I were to ask you,
King Henry died.
Chocolate milk.
okay, if I were to ask you, if we were dealing with meters, right, measuring length, which would be longer, a kilometer or a decimeter?
Kilometer.
Jess, what do you think would be longer, a kilometer or a decimeter? Which one? Kilometer? Do you agree?
Yes. Kind. Yes.
Yeah?
I agree. Yes. Yeah, I agree.
Yeah? Okay, because the meter is our base. Okay? So if we had meters, right? 6 meters would be 6 meters.
What is a base?
6 kilometers would be 6,000 meters. Okay? That would probably be from here to like Jack in the Box. Okay? Pretty far. But if we had 6 centimeters, right? Centimeters are tiny. Centi,
Millimeters are
right?
tiny.
Deci, centi, milli, those are fractions of your whole unit, meter. Okay? So not even a whole unit, but like a small piece of it. Okay? So if I had decaliters and hectoliters, which would be more? Nasalo.
Base. Oh.
Decaliters or hectometers?
Hectoliter.
Yeah? Why?
Because it says 100.
What?
Because it's 100 on the bottom.
Like a fraction?
Yeah.
So this is not even a full liter?
Oh, no. I don't know.
Ashlyn, what do you think? Is he right? Hectometer?
Yeah.
Why?
Because a hectometer is 1 meter times 100, but a deciliter is 1 meter times 10.
Yeah. So this is 10 times bigger. This is 100 times bigger. This is 1,000 times bigger. Okay? Or this is 10 times bigger than a deciliter. right? This is 100 times bigger than a deciliter.
What is
Okay.
the base?
The base is your main unit. So liter, meter,
Kilo.
no. What else do they
What
measure?
about
Centimeter. Okay. Damian brings up a good point. What about gallon? Do we have decagallons?
gallons? Yeah, we have a
Kilogallons? No. So this is only used with metric measurements. Leave the board on the floor, please. Okay. This is only used with metric measurements. We don't use this for our like inches, feet, yards, gallons. Okay. This is just a way to break things down more. Okay. So a kilometer or a kilometer might be about the same length as a couple of miles. Okay. So they break it down in base 10. We don't. Okay. We have like gallons, quarts, pints. Remember gallon man? Yeah. Okay. All right. Here's what I'm going to have you guys do next. Okay. I want you to work on problem solving number 4. Okay. So there are 6 problems. Some of them are division. Some of them are working with units. Okay. Use the bar model method to help you. Okay. Now, there might not be enough room on the bottom of this, but you can use the back. You can use scratch paper. Okay. You can, no, you may not use the board because you can't staple the board to the back of this. Okay. I will leave this up here so you can remember.
Yay! How can they
Okay.
die?
King Henry died drinking chocolate milk. Okay. So if you had a base, right? A base unit of meters, right? And it said how many decameters were in 6 meters?
Decameters.
This is what you do, right? Multiply it by 10. Okay. If it said I had centimeters, this is what you do. Divide it by 100. Okay. Okay. I will work with a few of you, but the rest of you, I want you to try it on your own because I want to see for tomorrow, do we have to go over the bar method again? I mean, I know we have to, but what about it do we have to review? Okay. Oh, scouts. Let's check in with you before you head off. Who did you see exhibiting good behavior?
I saw Ilana doing following the
Thank you.
Okay. Why? Why was she exhibiting good behavior?
because instead of playing around, she was listening to you while you were teaching. And
Okay. Okay. Anybody else?
I saw Leilani doing the same thing.
Okay. Why? Why was she being a self-directed learner?
She was also doing her work and she was paying attention to it.
Okay. Thank you. Dominic. Okay, thank you. Pass that to Kervin, please. Okay. Anybody else? Okay. Okay, very good. Thank you. Yes, I saw them too. All right. Before recess, I'll check in with you guys again. So you still have a chance to win dolphin tickets. Dolphin store is next week, Monday.
What?
minutes?
Yeah.
Did you be doing the clicking?
What?
I'll check.
I maybe have. I don't even know.
Okay. Can I have from Damian to Nima stand up, go back to your seats?
How could he die from chocolate?
Because you keep on drinking and there's like a lot of sugar. Like sodium.
Get that.
Okay.
I know.
The rest of you stand up. Okay. Can I see
Anthony.
can I see Jess,
Anthony.
Nasilo,
Yay!
Ashlyn, and Damian down on the floor? Yes.
I need help.
I will come. I want to help these guys first. Okay. If I did not call your name, please stay at your seats. You can get started.
Only have one dolphin.
Hold on to it. Can you write Taimane's name on one of them, please? Thank you.
She always does that.
Okay. I will be calling more people down. Okay, so if you need help, you need to at least start. Okay. Huh?
Oh, you need a pencil?
Yes.
Oh.
Yes. Sit closer. Thank you. Okay.
Today the 16th.
Yes, today is the 16th.
Okay, let's start.
Okay. Let's start with A. Okay. Three families are vacationing together. They are equally sharing the hotel costs, which is $2,634. Manuel's family is also renting a car for $348. How much will Manuel's family have to pay for the car rental and the hotel together? Okay.
You have to add it.
Okay, so let's break this down. Okay, what is the question asking us to do? So let's write our math statement first. Nasilo, what do you think our math statement's going to be?
Oh, so you're asking what the question was.
Oh yeah, what is the question?
How much will Manuel's family have to pay for the car rental and the hotel?
Oh, okay, so how would you change that into a statement?
The Manuel family has
So Manuel's family will pay, okay, for
the car rental and the hotel.
Okay. All right. Okay. So let's go through each part of the question. Okay. Three families are vacationing together. Stop. Okay. So how many families are we dealing with? Three. Oop, wait a minute.
Read the other two.
Yeah, but you gotta help divide.
Okay, 3 families. Okay, they are equally sharing the hotel cost, which is $2,634. Stop. Okay. So how much was the hotel?
We don't know.
I know.
Careful. How much was the hotel, Ashlyn? Okay. And is that how much one family is paying?
No, that's how much all of them.
Oh, that's how much all of them are paying. Okay, so I'm gonna start drawing the bars. Okay. So all of them are paying $2,634. Manuel's family is also renting a car for $348. Okay, so they have an added cost of a car. How much is that car? Okay, $348. I'm gonna write that up there for now. Okay, this is just for Manuel's family, so I just wrote that up there to remind myself. Okay. So we said this hotel money, right? They're equally sharing it. Okay, so all 3 families are equally sharing this amount. Okay. So if 3 families are sharing this amount, how do we figure out what one family is sharing, is paying? Damian. Okay, so what am I going to divide? Why by 3?
Because there's 3 families and they're sharing the $2,634.
Good. Okay. Let's do standard algorithm because we need practice with that.
Can we do short?
Okay. 2 cannot, or 3 cannot fit into 2, so let's make it 26. Yeah, that's what we're doing.
How we doing short?
So each number at a time. You cannot divide 2 things among 3 people evenly. Yeah. So we have to make it 26. So 3 can fit into 26. We can get something close. Yeah. Okay. So how do we get to 24? 3 times what gives me 24? 8. Okay. 3 times 8 is 24. Okay. So now we have 23. Well, obviously we can't use 8 because 8 gave us 24. Okay. So let's do one number down times one number below 8. One number below 8.
7.
Yes. Okay. 3 times 7 is how much?
21.
Okay. Three can fit into 24 evenly?
Yes.
Okay.
By
8 times 3 is 24. Yep. Okay. So how much is each family paying for their hotel?
8. 878.
Okay. But is that what our question's asking? No? Okay. No, it's not. There's one more step we have to take because we're talking about Manuel's family. What was the other step we had to take, Ashlyn?
You have to add how much they have to pay for the car rental and how much they have to pay for the hotel.
Okay, yeah. So Manuel's family, theirs actually looks like this. Okay.
I got it.
Because we have 878 for the hotel and 348 for the car. Okay?
I got 1,226. I got 1,226.
Yeah, you already said it.
Okay. So Manuel's family will pay how much for the car and the hotel?
1,220.
Okay. Oop, what am I thinking?
Oh,
Okay. For his car and his hotel. All right. Is it easier to see what to do when you draw out the bar like this? Yeah? Because then you can see, right, you need to divide it up into 3 pieces. They're all equal. This is actually Manuel's family's money, how much they're paying. Okay. Okay. Do you think you can do the rest of the problems on your own? Yeah? Do you want to do a practice conversion problem?
what? There's those problems too?
Yeah? The very last one.
Can we try to do the B, but then we do the try and do the answer and then check it for
B? You want to do B?
Yeah, we do it all at once and see.
Well, at the end, before we go to recess, I'm hoping that I can bring everybody back and talk to them about it.
Can we do F?
Okay? You want to do F? Okay. Girls, do you want to do F? Or do you think you're confident doing it by yourself? You want to do F? Okay, we'll do F.
Is that the only problem that has
No. D, E, and F are both working with measurement.
The last 3?
But we'll do F together. Okay. In 1990, the Olympic marathon distance was 40.26 kilometers, and in 1906, it was 41.86 kilometers. Then, in 1924, the distance was fixed at 42.195 kilometers. How many more meters is the current marathon distance than the 1900 distance? Okay. So, what is our math? What's the question asking us to find out? What's our math statement?
How many more?
Remember, statement, not question. Statement. Damien.
Link meters is
Okay. So the current marathon
Distance is
is blank meters longer or shorter?
longer.
Okay. Than the 1900 distance. Okay. So the current marathon distance is some meter longer than the 1900 distance. Okay. So in 1990, the Olympic marathon distance was 40.26 kilometers. Okay. Oh, I'm sorry, not 1990, 1900. Okay, so in 1900. In 1906, it was 41.86. Am I going to make my bar longer than this one or shorter than this one?
Shorter.
41 point
Oh no, longer.
longer. Okay. So remember, I'm not making it the same size. I'm going to make it a little bit longer because it was a little bit longer. 41.86. Okay. And this was in 1906, right? The current 1924, it was raised to 42.195. Okay, so am I going to make it longer, equal, or shorter? Longer. So in 1924, it was raised to 42.195 kilometers. Sorry. Okay. The current marathon distance, so this is the current marathon distance, is blank meters longer than the 1900 distance. So did it talk about the 1906 one at all in our question? No. So we don't need to concern ourselves with this one. Okay? So this one, out. Don't worry about it. Okay? The only thing the question is asking us to compare is the one from 1924 to the one in 1900. Okay? So how much longer was this one compared to that one? Okay? What operation do you think we would use? You're going to subtract? Yeah. Because I need to know if I were to make this the same, right? What is this piece? Okay? So here's what I need to find out.
Can we erase the 1906?
Huh? Yeah. Okay. So here's what I need to find out. Okay. What's the first thing you would do when you're subtracting these two decimals? Add a
0.
Okay. Does that change the value of 40.26? No. Okay. All it does is it allows me to subtract this a little bit easier. Okay. Okay. 5 take away nothing is going to be 5. 9 take away 6.
3.
Okay. 1 take away 2. Cannot. Okay. So I need to regroup. So I'm going to take from here and put over here. 11 take away 2.
9.
Okay. 1 take away nothing. 4 take away 4.
0.
So the answer is this marathon is 1.935 or 1 and 935 thousandths of a kilometer longer. Somebody want to check it? How would you check it?
You add
Ashlyn?
the answer you got with the 40.226
Yep.
to see if you get 42.1.
Okay. Did you check it? Is that what we got? Yeah? Okay.
Yeah.
Awesome. All right. You guys can head back to your seats. So Sorry. I was just gonna pretty much do the same thing with another group. I don't know if you wanted to film it because it's 9 already. Yeah, you're good? Okay. Did you want to do the post interview now? I mean, I can work with David. We could just do it, get it out of the way now. Because recess, honestly, recess is only like 10 minutes.
Yeah, totally.
Okay. Because they're fine. They're fine working. I can just sit outside
Yeah.